Hi everyone. Oh, and I'm working on borrowed time battery-wise, but we'll see what happens here. Um, this video is going to continue with our lesson on trig, and it's getting into how do we use these trigonometric ratios to find a missing side length, okay? So to start this out, you'll notice that now instead of having all the side lengths like I did up above, I only have one, and I have an angle, and then I have a missing side, okay? So the first question is, which trigonometric ratio is going to help me here? And here's how I figure that out. If this is my angle, I look at the side that I already know and the side that I'm trying to find. And I always refer to this as, here's the one you know, here's the one you want, and this is the don't know, don't care side. Okay, we don't know what this is, and we don't need to know what it is. So this is the one we're not going to use in our ratio. So the 34, because it's across from the 90, that's my hypotenuse. And the x, because it's across from the 22, is my opposite side. Okay? So opposite and hypotenuse, if you go back to SOHCAHTOA up here, opposite and hypotenuse is the sine ratio. So I want to set this thing up with the sine ratio. By the way, SIN is the abbreviation for sine. It is not sin. Please make sure you're saying it as sine, just so you sound like you know what you're talking about. And instead of saying like sine of A, like we did here, we have an actual angle measure now. Do you see how back here we didn't know what A was, but now we know. So we can say sine of 22, and then we can set up our fraction. It's supposed to be opposite over hypotenuse, so that would be x over 34. And then our goal is to solve for x. Now I want to show you something quick here. Sine of 22 we can find in our calculator. Let's see. So if we hit sine 22, we get this big crazy decimal. And I just want to clarify what that represents. That means that anytime I have a 22-degree angle here, the relationship between the opposite side and the hypotenuse is going to be this 0.3746, okay? That if I took the hypotenuse and multiplied by that decimal, it would give me the opposite side, okay? That's how much smaller this is than this in every right triangle that has a 22-degree angle. But I'm not going to write that decimal down right now. I'm going to do some math first. And I think every teacher approaches this step a little differently, so if you have learned a different way and you're happy with that, that's fine. But I always think of this as a proportion. I always put this over 1, and then I cross multiply. So I end up with 34 times sine of 22 equals, and then this would just be x times 1, which is just x. Okay? And this is nice when x is all by itself because it means that all I need to do is this calculation. And notice I'm leaving that sine of 22 just like that rather than replacing it with the decimal because I just don't want to write that decimal a bunch of times. So in my calculator now, I'm just going to type in 34 times sine of 22, and I end up with 12.73. Actually, it says round to the nearest tenth, so we're going to say 12.7. And so I was able to just find the length of this side right here. Okay, should be 12.7. Just check your answers and make sure they're reasonable with the other sides that are already there, but that one seems to work. Okay, so with this second one here, this is the angle I'm starting at. And remember, I need to figure out which trig ratio I even want to use. Okay, come on, computer. Let's see. So I'm going to label my sides based on that angle. I always start by finding the hypotenuse, because that's the easiest. It's across from the 90. The hypotenuse is this one here. That's my don't know, don't care side. Okay, but I'll label it anyway, because we went to the trouble of finding it. From the 38 degrees, this would be the opposite side. And then next to the 38 degrees, this is my adjacent side. And again, the hypotenuse is the one that we're not really going to end up using in this one, because I need to make sure I involve my x and the 20. So opposite and adjacent, that's going to be tangent, TOA. So opposite and adjacent is tangent. So this one's going to set up like this. Tangent of the angle, so tangent of 38, equals opposite over adjacent. So that's 20 over x. And then again, depending on your teacher last year, you may have learned a different way of going about this next step. I always like to take this and put this over 1 and cross multiply. And you're going to get good enough at these that you'll be able to take some shortcuts. But I do want you to notice that this one's going to work out differently. This is going to work out like x times tan 38 equals 20. And then if I'm trying to get x by itself, I would come in here and I would divide by tan 38. So in my calculator, this is what I'm doing. 20 divided by tan 38. And I get 25.6. Again, I'm kind of looking at it, making sure that it seems to be reasonable with my other side lengths. It does. So I'm good with that answer. So every one of these problems where you're finding like a missing side length is going to either come down to multiplication like this one did, or a division problem like this one did. Okay? And you'll start to recognize them after you do quite a few. But if you're stuck and you're not sure, do I multiply, do I divide, I would set it up like this proportion just like I did here. Okay, one more quick segment that's going to talk about finding missing angle measures, and then we'll be good to go.